Hey everybody, welcome to the intro video for our Unit 8 on scientific notation. And later on in the video, I'm going to kind of talk about scientific notation, what it is and why we need it. But there's a skill set that we're going to need before we even get to that part of the video. And it's actually going to be something that we're going to look at and just trying to see how you are at recognizing any patterns. One of the things that as humans we're best at is actually our ability to recognize patterns. So in this first part right here, I've got a 10 to the first power, a 10 to the second, a 10 to the third, and a 10 to the fourth. And I want you to take a look real quick and see if you can notice a pattern between the fact that 10 to the first here is a 10, 10 squared is 100, 10 cubed is 1,000, and 10 to the fourth power is 10,000. Now in a calculator, we can actually multiply it out. For example, 10 squared is going to be a 10 times 10, and that's where we get the 100. If we did 10 times 10 times 10 a third time, we'd get the 1,000. And if I did it times 10 again a fourth time, that's where we get the 10,000. So at this point, you might already see the little pattern here is whatever the exponent is, it just tells you how many zeros there are. So if I were to ask you guys right now in your notes to put down what you think 10 to the fifth power would be, go ahead and jot down what you think 10 to the fifth power is going to look like. And then also let's jot down what you think 10 to the sixth power is going to look like. Okay. In the calculator, I'll show you if we did this times 10 again. So 10 to the fifth power is going to be 100,000. So that's what you should have written down right here. And then if I do times 10 again, so this is 10 times itself 6 times, y'all. And here we're going to get 1,000,000. All right. So let's make sure you guys got those numbers written down right here. We're going to have 100,000 for 10 to the fifth power. There's the 5 zeros. And then 1,000,000 is going to look like this with our 6 zeros. Now, if we notice that we have an exponent here that just tells us the number of zeros that we're going to need on the right-hand side, the shortcut also works if we look at the negative exponents here. Notice if you see a 10 to the negative 1 and a 10 to the negative 2, a 10 to the negative 3, and a 10 to the negative 4, it's still the same number of zeros, except this time they're just on the left-hand side because they were negative. So if I have 10 to the negative first power, that's the same thing as 1/10. And I did include the fractions just so you guys would remember that when you see this decimal right here, this decimal is 1/10. When you see this decimal right here, this is 1/100th. When you see the 3 decimals, again, 10 to the negative 3, we see 1, 2, 3. That's going to be 1/1000th. And if you see a 10 to the negative 4 with the 4 zeros there, that's going to be a 1/10,000th. So similarly as over here, if we have a 10 to the negative 5, it's going to be 5 zeros, so 0 point, that's one of them. 2, 3, 4, 5, there's your 5 zeros, and then a 1. And then if it was 10 to the negative 6, it'd be the same thing, it's just going to be 6 of them. So 1.2, 3, 4, 5, 6. There's your 6 zeros, and then a 1. So this is going to be 1/100,000th, and this is 1/1,000,000th. That's how we say those, okay? So now for our little hint, this is again the shortcut. We've recognized a little pattern here. You can just use the exponents to tell you what the number should look like. And if it's a positive exponent, the zeros were on the right, okay? And if we had a negative exponent, the zeros were on the left of our 1 here, okay? So now real quick, let's just do some matching. We've got 5 problems here where we're just going to match. If we see 10 to the fifth power, it's a positive, so we should see 5 zeros on the right-hand side. Here are the 5 zeros I'm talking about on the right. So number 1 here matches up with D. For the next one, if we see a negative 3, we should see 3 zeros, but to the left. So here are the 3 zeros to the left of 1, including 0.001. So we've got E. 10 squared is 100. So 10 times 10 here. There's the 2 zeros to the right. That's a positive exponent. So that one's going to match up with A. All right, if we see a negative exponent, we know that that's the same as seeing a decimal answer, and it's going to be to the left. So this one matches up with C. And 10 to the fourth, we should see 4 zeros to the right, and here's the 4 zeros to the right. So this one matches up with B. So all we're doing so far is learning how to identify if we see 10 to a certain exponent, whether it's positive or negative, we want to see what number we're actually dealing with over here. Now, not right this second, but you're going to have a Google form for a place for you to answer questions 6, 7, 8, 9, 10, and 11, just to see how you're doing on just this part, where if you see like a 10 to the negative fifth, which one of these is it? If it's like a 10 to the seventh, which one of these is it? And you might also see, of course, here a question that says which two are not the same as this. So this is a place for you to just practice those questions, and there's going to be a Google form for you guys on those problems. All right. So go ahead and let's flip over now with me. And so we're on the back here. And this chart looks incredibly boring and stupid, and it's supposed to look incredibly boring and stupid. And the reason I want it to look incredibly boring and stupid is so that if I talk about there's a shortcut, a way to avoid all this stuff, you'll be like, yep, let me avoid this boring, stupid chart. All right, so the first thing I'm going to point out that we're trying to accomplish is something like this. If I want you to multiply something like this, I might want you to multiply something like this. Think about how terrible it looks. If I was like, okay, guys, we're just going to multiply these numbers, and in the chart, I want you to just fill out the chart and use a calculator, and you can just multiply them all. So for example, let's just start with the first one. If I do a 5.012 times 10, and like I said, this is supposed to feel like torture, okay? This is supposed to be awful. Sorry, let me get this in the calculator. 5.012. All right, so times 10 to the first power is 50.12. Okay, so the answer to the first one here is a 50.12. What if I wanted you to do 5.012 times 100 instead? Well, this would be our answer, 501.2. All right, what if I wanted you to do this one instead? 5.012 times 1,000. All right, we get 5,012. Now, some of you might already be starting to notice a pattern here, okay? As I'm going through these, if you're noticing a pattern, that's what I want to happen. I want you to notice a pattern in the answers, and as you see the pattern develop, you'll start to say, can I stop using the calculator and can't I just keep the pattern going? And the answer is going to be yes. All right, for the next problem, if it's 5.012 times 10 to the fourth power, it's really a 5.012 times 10,000. So in the calculator, 5.012 times 10,000 is 50,120. All right, and next one we hear 5.012 times 100,000. 501,200. So let's stop real quick and talk about the pattern together, okay, y'all? When it was just times 10, which is of course 10 to the first power, notice that the answer just takes the decimal and moves it over once, and we get a 50.12. When it was times 10 squared or times 100, the answer is, if I had just moved the decimal over twice, I get 501.2. So let's keep looking at this exponent here. If I have a number times 10 cubed, I can just move this decimal once, twice, 3 times, and I get this answer. When it's 5.012 times 10 to the fourth, notice that I'm going to just move this over 1, 2, 3 times, and if I fill in this fourth spot with a 0, I get the exact same answer over here. And the 5.012 times 10 to the fifth, if the decimal was right here for 5.012, 1, 2, 3, and then I fill in 4, 5 spots with zeros. And so what you guys are learning here is that this right here is really a shortcut for seeing a super long multiplication problem like this. And we can actually simply use the shortcut to just move the decimal, and we don't even need to use the calculator to get the answer. All right, so let's practice. If we saw times 10 to the sixth, which is the same as seeing 5.012 times 10 to the times a million. If I wanted you to just multiply 5.012 times a million, all you've got to do is take that decimal and move it 1, 2, 3, 4, 5, 6 times. And there was the 0, 1, 2, and we're going to fill in the rest with 0, 0, 0. So let's see what that number looks like in the calculator. 5.012 times the million. So today's video is all about math shortcuts, And right here, you can see the 5,012,000 that we get. And even though it looks a little sloppy over here, there's the 5,000,012,000. There's the 5,012,000. So let's just keep going down here with the hundredths place value. Notice that up here we had a 5.012. This was a number that went all the way out to the thousandths. We're going to practice here real quick if we see just numbers to the hundredth spot, and then we'll finish up down here if we see only numbers in the 10th spot, okay? Then we'll worry about the second half over here, all these negative things, okay? So again, 8.22 times 10 to the first power, that's like seeing 8.22 just times 10 over here. So we get 82.2. So let's go ahead and jot that down, 82.2. All right, now we've got 8.22 times 10 squared, which is 100. All right, 822. Again, we can see that pattern. If I just took the decimal and moved it over once, there's the 82.2. Now if it's 10 squared, if I move it twice, there's the 822. So if I move this over 3 times, 1, 2, 3, there's the 2, 2, and we'll fill it in with a 0. So this is going to be 8,220, 8,220. And we can check our math in the calculator. 8.22 times 1,000, there it is, 8,220. So if we had 8.22 times 10,000, okay, so let's just check it. If I had the 8.22 here, and I go 1, 2, 3, 4, and I fill in with zeros, I could put a comma here to help you guys see that that's the 82,200, 82,200. All right, so now 8.22 times 10 to the 5th, which is 100,000. So we get 822,000. And for the last one, it's going to be 8.22 times a million. Whoops, let me go back. There we go. And we get this number right here, 8,220,000. So 8 for this one, 822,000 for 10 to the 5th. Okay. All right, and so we've seen what happens if we have 3 decimal places as we're moving things over. We've seen what happens if we have 2 decimal places as we move things over. And now last but not least here, let's just review if we have 1 decimal place. Of course, the 1 exponent, it's still just going to move it over once. So 3.9 now is a 39. If we move it over twice, we've got 1, 2, so we'll need to fill in with 1, 0. So this is going to be a 390. I'm going to move this over 1, 2, 3 times. So this is going to be 3,900. All right, for the next one, we're going to move the decimal 4 times. So that would be 1, 2, 3, 4. So we'll fill in with these zeros here. So this is 39,000. And this is going to be 390,000. Again, because 1, 2, 3, 4, 5. Okay, 5 times. And the last one here, 3.9 times 10 to the 6th. So if we got a 3.9 times a million, 3.9 million. Okay, 3.9 million. All right, so go ahead and jot that down right here. So the answers that we've been getting each time, y'all, here with the pattern, these answers are called standard form, which just makes sense because now we've been going from this weird looking multiplication problem to just telling me the answer. Like you're literally just telling me what the answer is of this multiplication problem, and that's just called standard form. And so the actual multiplication problem that looks weird here with the exponent, that's the new vocab word for today, and that's the thing that's called scientific notation. So scientific notation is just a way here to see like a long multiplication problem like this written with a shortcut and an exponent so that now you can simply just use that exponent to move the decimal over, and it can be just a very quick thing that you can do on the spot and you don't even need to take the time to do it in the calculator. Now, if we saw positive exponents here and the positive exponents had us moving our decimal kind of like to the right, now let's look briefly at what happens when we see these negative exponents. And as you might have predicted, it's simply just going to move the decimal backwards to the left. So real quick, let me just review and remind you that this 10 to the negative 1, that's what you guys did on page 1. 10 to the negative 2 was this thingy. 10 to the negative 3 was this. 10 to the negative 4 was this. 10 to the negative 5 was this part. And 10 to the negative 6 is this. So if I were to be super annoying and say, hey, let's just multiply 5.012 times 1/10. Instead of having to get the calculator out, which we can do, I can do 5.012 times 0.1, and I can get this decimal, okay? Or we can just use the shortcut of moving this thing back once, and now we've got a 0.5012. All right? Now again, this second problem, this could be very annoying if I were to make you multiply that. And if I was like, you can use a calculator, you'd say, okay, not so bad. I'll just multiply it in a calculator times 0.01. And this is the answer you'd get. Or you can just move the decimal here back twice. So let me show you guys. I'm going to pull the calculator back up in a second. But if I have my original 5.012, if I move this back once, twice, and I fill in with a 0, I get 0.05012, and the calculator just simply shows the 0 point out in front of it. And now you guys are going to love this. Check it out. I mean, if you see times 10 to the negative 2, there are still those 2 zeros to the left that we talk about. When it's times 10 to the negative 3, we're going to see 1, 2, 3, and then here's the 5012. When it's 10 to the negative 4, we're going to see 1, 2, 3, 4, and then the number 5012. When it's 10 to the negative 5, you got 1, 2, 3, 4, 5, 5012. And if you don't believe me, I mean, we can be super annoying and check it in the calculator. So 5.012 times the 1/1000, 1/1000th. And there it is. Okay. So for the last one here, that 5.012 times 10 to the negative 6, here's the 1, 2, 3, 4, 5, 6 zeros, and then our number. All right, so now let's say we had an 8.22. All right, so here's the 8.22. We have 2 decimal places over here. I move it back once, and I have a 0.822. This answer is now a 0.822. And to help you guys see it, I just do times a 10th. There's the 0.822. All right, so now we're just going to put the 0 in front of it and remind ourselves that if it's 10 to the negative 1, I should see 1 0. If it's 10 to the negative 2, I should see 2 zeros. If it's 10 to the negative 3, I should see 3 zeros. If it's 10 to the negative 4, I should see 4 zeros. If it's 10 to the negative 5, we should see 5 zeros. Again, this is just pattern day. This is pattern day. This is all it is. We can't forget those 822s at the end of all of this. And it looks like right here, looks like I forgot to adjust those numbers to look like these right here. So that's my bad. But if we saw 8.22 times 10 to the negative 6, I'm going to have 6 zeros. 1, 2, 3, 4, 5, 6, and then we got 822. Sorry, that does not look like an 8. Let me erase that. 1, 2, 3, 4, 5, 6, and then 822. Cool. All right. Now, just for the sake of time, I mean, I think you guys get the point here. We're going to skip over that part. I'm not too worried about that for right now. But let's just practice again, like just so that you guys are okay with the entire point of the video here. If I see a 390,000, if I give you this number, I want to know what it is in scientific notation. So 390,000, we can see it right here. Here's 390,000, 390,000. So that's 3.9 times 10 to the fifth. The 822 we saw was up here. If we got that, that was 8.22 times 10 squared. And the 5,012, that was up here. 5,012 is right there. We got that number up there. So that's going to be 5.012 times 10 cubed. 5.012 times 10 cubed. Okay? Now for these, remember that shortcut, we see 1, 2, 3, 4, 5, and they're on the left-hand side. So this is a 3.9. This is the 1 times 10 to the negative fifth. Here we see the 822, but the 2 zeros are on the left. So this is going to be the 8.22 times 10 to the negative 2. And here we see the 512, the 5.12, and it was 1, 2, 3. So this is 5.12 times 10 to the negative 3. Times 10 to the negative 3. Okay? All right, that concludes this video for right now. There will be another one ready and waiting for you. Thank you.